Why do some rockets accelerate faster than other rockets? Why do some cars accelerate faster than other cars? Why do some athletes accelerate faster than other athletes? Why do some balls, baseballs, softballs, golf balls, volleyballs, soccer balls, accelerate faster than other balls? In this investigation, we're going to try to find the answer to those questions and learn a pattern or a rule that Sir Isaac Newton found many years ago. The big question we are trying to answer is, how does mass affect acceleration? So what I'm going to do for today is a demonstration. For the demonstration, I have a cart here that has a force sensor attached to it, as well as an accelerometer. An accelerometer is a device used in order to measure the acceleration in an object. It's used sometimes in airbags, and when the acceleration gets too big, then the airbag goes off to protect the driver or passengers in a car. What I'm going to do is I'm going to control the force. I'm going to put that on my y-axis of my graph, and you'll see why later on, but it actually is my independent variable. I'm going to control the force by pushing and pulling on the cart. That's the only unbalanced force. There's a force of gravity pulling down and a normal force pushing up, but those two forces are balancing each other out because the cart isn't accelerating in the vertical direction. So right now the forces are balanced and we see a constant velocity of the cart, but when I start applying an unbalanced force, the cart is going to start to accelerate. And what you're going to see on the screen here is a force versus time graph in the upper left, an acceleration versus time graph in the bottom left, and then a graph comparing the force and the acceleration over on the right. Before I get started, I want you to make your prediction. The purpose of this experiment is to determine the relationship between the net or unbalanced portion of the force, the mass, and the acceleration. So for your hypothesis, I want you to answer this question. If the net force increases, then the acceleration will. You can record your prediction as to whether you think it's going to increase, decrease, or stay the same. To help you answer that question, I want you to think about this. When you push on an object, how does the magnitude of the force affect its motion? If you push harder, is the change in motion smaller or larger? Do you think this is a direct or an inverse relationship? Now assume you have a bowling ball and a baseball, each suspended from a rope. If you hit each of those balls with a full swing of a baseball bat, which ball would change its motion by the greater amount? Okay. Give you a chance to think about that and record your answers. The next thing I want you to do is predict, how do you think the force versus time graph on the upper left will compare to the acceleration versus time graph on the bottom left? Then make your prediction as to what do you think the shape of the force versus the acceleration graph will be. Let's see if you're right. Here we go. Give you a second to examine all three graphs. Were your predictions correct? Next, I want you to look especially on that graph on the right, the force versus acceleration one. I'm going to put in a line of best fit into that scatter plot. You can see it goes up from left to right. What do you think the y-intercept of that graph should be? What do you think the slope of that graph means? To help you consider what the slope might mean, I'm going to add some mass to the cart and then repeat the experiment. How do you think the graph is going to look different with that additional mass? What was different? What was the same? Have you figured out what that slope of that graph might mean? If you predicted mass, you are correct. Let me find the mass of the cart with that additional mass on it. Get a mass of 1,250 grams, which should be 1.250 kilograms. And you can see my slope is pretty similar to that. There's always going to be some error in the measurement. I'm going to save my latest trial. I'll repeat it again without the extra mass. Put in the line of best fit from the latest run. You can see it's much less steep without that extra mass. We got a slope of 0.6059. We find out the mass of the cart without that extra mass. 738 grams or 0.738 kilograms, which is pretty close to the slope we have right there. So from that, can you develop an equation that will connect force, mass, and acceleration?